Okay, so we're starting a new section in Chapter 5. It's called Factor and Solve Polynomial Equations. And the objective is to be able to factor and solve polynomial equations by using special patterns. So a factorable polynomial with integer coefficients. So remember, a polynomial is like x squared plus 4x plus 4 or something like that. Integer coefficients, so those are positive or negative whole numbers. And a coefficient is the number in front of a variable, okay? It's factored out completely. It's broken down completely. So think of factoring as breaking it down into smaller parts. It's factored completely if it's written as a product of unfactorable polynomials with integer coefficients. So if it's broken down into things that can't be broken down anymore. Okay, that's how I think of it. So here's an example of something that has been factored completely. X plus 4 times x minus 7. And I'll just throw an x out there just for kicks, okay? So none of those terms can be broken down anymore, all right? That's as far as they'll go. Here's something that's not factored completely. X times x squared minus 16. And the reason why that's not factored completely is because this x squared minus 16, that's one of those special patterns that we've been talking about all year. It's called the difference of two squares pattern. This can get broken down more. So this can go to x times, and the difference of two squares, x plus 4, x minus 4. Okay? All right. So let's factor each of these completely. So if I look at this, I look at all my terms. I can first factor a y out. So I get y times y squared minus 4y minus 12. Okay. And again, we're paying attention. We want these integer coefficients. We want whole numbers. We don't want fractions. So now I look at this quadratic right here, and I say, okay, can this get broken down more? Can I find two numbers that multiply to make negative 12 and add up to negative 4? And I can. It's negative 6 and positive 2. So factored all the way out, it's y times y minus 6 times y plus 2. And those can't get broken down anymore, so I'm done. My mouse here. Okay. For part B, 3x cubed plus 30x squared plus 75x. Okay, the first thing I can factor out of all three of these terms is a 3 and an x. They all have that in common. So if I factor that out of 3x cubed, I get x squared. If I factor it out of 30x squared, I get positive 10x. And if I factor it out of 75x, I get positive 25. Okay, so now I'm looking for two numbers that multiply to make positive 25 and add to 10. It's 5. And that's actually a perfect square trinomial. It's what you get when you multiply the same binomial by itself, x plus 5 times x plus 5. So my broken down answer is 3x times x plus 5 times x plus 5. Or you could also say 3x times x plus 5 squared. This one, 5g to the 5th minus 80g cubed. So a common factor is 5g cubed. I can factor that out of all of them. So what I'm left with here is a g squared. And then 5 times negative 16 gets me to 80. Okay. And now, I saw in that previous example, this is the difference of two squares. And now it can't be broken down anymore. Okay. For the U-try part, I'd recommend that if you can, pause the video and then try these on your own. If you're totally stuck, go ahead and start the video back up again. All right, now that you've tried, check your answer. First, I'm going to factor an x out of here. So I get x squared minus 7x plus 10. I'm looking for two numbers that multiply to make 10 and add to negative 7. That would be negative 5 and negative 2. So what I'm left with is x minus 5 and x minus 2. And then you have that x out front. common factor here, 3y cubed. When I factor that out, I get a y squared, and I get minus 25. That's the difference of two squares. So the square root of 25 is 5, so the pattern is y plus 5, y minus 5. Okay. All right, here's some more patterns. The sum of two cubes. So if I have a cubed plus b cubed, it can get broken down this way. A plus b times a squared minus ab plus b squared. The difference of two cubes is very similar. Notice I have a subtraction sign here in this one. My subtraction sign will be here in this pattern. Okay? So let's do a couple of examples. I'm going to do two different ones. I'm going to do x cubed plus 27. Okay. So that's really the same thing as x cubed plus 3 cubed. So that's my a, and my b equals 3. So now I'm just going to plug them into that pattern. So I get a plus b, okay, x plus 3. That's what I'm substituting in. My first number squared, x squared. Then I multiply the two of them and subtract, minus 3x. I'm going to circle that. And then I square my b value, plus 9. I'm all done. All right, here's one that's a little trickier. I have 8x cubed plus, let's go plus 27 again, just to keep it kind of easier. So now my a value, 8, is 2 cubed. So this is going to be 2x cubed. All right, so my a value is 2x. So I'm going to rewrite it this way, plus 3 cubed. So 2x plus 3, just substitute them in there. Then for my first one, 2x squared, so you got to square the 2 and the x, you get 4x squared. Now I multiply them together. 2x times 3 is 6x. 3 squared is 9. Okay. All right, the difference of two cubes. Pretty much exactly the same thing. The only difference is you change the signs. Okay, so the example I have is 64x cubed minus 1. So 64x cubed, that is 4x cubed. So my a value is 4x, and my b value is 1. So I'm going to plug it into the pattern. So a minus b, 4x minus 1, times a squared. So my a value was 4x. If I square that, I get 16x squared, plus a times b, 4x times 1. So it's just 4x plus b squared. 1 squared is 1. And I'm all set. That's done. It cannot be factored down anymore. Okay. Let's go ahead and we're going to get through example 2. So 27x cubed plus 125. So this is the same thing as 3x cubed plus 5 cubed. So my a equals 3x. And my b equals 5. So I'm just going to plug it into the pattern. So I'm going to copy down the pattern here really quick. And then plug it in. Wherever I see an a, I put a 3x. Wherever I see a b, I put a 5. A squared is 3x squared, so 3 squared is 9. A times b, 3 times 5 is negative 15x, because we're subtracting. And then b squared, 5 squared is 25. Okay. And one more. Let's go ahead. We can factor a negative 2d squared out of both of these. So I think these are actually kind of fun because what you can do is you can sort of look for how can I break this down? How can I, sort of like solving a puzzle backwards. Okay, so this negative 2d squared, nothing we can do with this, but this d cubed minus 25, that's the difference of two cubes. So d, or my a value equals d, my b value, 5 cubed is 125, so it's 5. So now I just plug that in. I'm going to write the pattern here really fast. The more you write the pattern out, the quicker you're going to be to memorize it. So I have that negative 2d squared out front. And now I'm just going to plug in a is d, so d minus 5. And then everything is being added. So now I square my a value, was d. I multiply the two together. And then I square my b value. It's 25. And we're all set.